What's up, PyTexas? It's good to be here. Woo! Thank you, thank you. My name is Pandy Knight. I'm the automation panda. I think it can be said it's not PyTexas until the panda talks about testing. True story, this is my favorite conference. I love it here. I'm very grateful. Please forgive me if my voice is a little cracked or I cough. I'm overcoming pneumonia. Don't worry, I'm not contagious. I'm just a little icky still. But that's not going to stop us today from good testing, is it? Today, we are going to build a test framework from scratch. Yes, it shall come to pass. Now, what is a test framework? I want to be very careful in defining this because sometimes you might think, well, is it the whole project? Is it the test cases? No. When I'm talking about a test framework specifically, I'm talking about a programming structure for coding automated tests, executing them together as a suite, and reporting their results. Think about your tests like dominoes. The test framework is the thing that lines them all up, knocks them all over, and says, good job. That is the part that's the test framework, not the test cases themselves, not the packages you put in it, but that raw execution machine. And so the framework works together with the test cases to make what we would call a test project. That's the difference between the test cases and the test framework. Now, if we're going to build a test framework together, we need something to test, don't we? And so I've put together a little bit of Python code that I think is pretty cool, and it comes with a bit of a setup story. So as many of you know, I'm actually not from Texas. Oh, horrible, I know. I could see myself living here. I love Texas barbecue. I like it more than where I'm from, North Carolina. Don't tell anybody that. That's our PyTexas secret. I still love Carolina barbecue, but of all the 4 great traditions, Texas is actually my favorite. I can say this because I'm actually from Baltimore. But I am from the Triangle of North Carolina. And in the Triangle, like in Texas, if you want to get anywhere, you have to use a car. You have to drive. I would love to have an awesome public transit system that kind of looks like this, where you've got like monorails and subway lines and bike share and I would love to live in this kind of city. So in my future dream version of the Triangle, we have this awesome public transit system. And with a public transit system, that means you need to buy tickets in order to use it. So what if you had an app on your phone where you could buy tickets for public transit, and if you wanted to buy a one-time ticket, you would purchase it and you get a QR code that anytime you get on a bus or a train or a monorail or whatever kind of public transit, you go beep, boop, boom to the scanner and it scans your code. And inside of this code, it houses your decoded commuter ID, which identifies you as the passenger, but also it has some sort of security token to identify that it is actually you being issued with this particular ticket and not somebody just taking your code and randomly using it. So what we are going to test is the creation of this QR code in part of the larger scheme of the application. It's actually pretty easy to create QR codes in Python. Has anybody done it before? Yeah, I just pip install everything and it's great. It's magic applying, right? So there's 2 packages we need. We need the QR code package, which generates the QR code in pure Python. And then you also need to get Pillow for imaging and stuff. So it's required by QR code. So pip install all these wonderful things. Now let's get into some Python code. It's actually not too bad. So in my qrcodes.py module, I need to import the CV2, OS, and QR code. Just trust me. Then I'm going to write a Python function called generate payment code. It takes in your commuter ID. It takes in your security token. Those are those 2 pieces we saw before. And then a file path for where you're going to save this file. And so you can read the code here. It's not doing anything great. It's doing a little bit of error checking, make sure your file path is good, and then it's creating the data by concatenating your commuter ID with your security token, and then it's turning that into a QR code image and saving it to your file path. Very straightforward. Thanks, Python. You did the hard work for me. We also have the flip side, where we need a function to scan the payment code, because it's one thing to create it, but then you need the scanner to scan it. And so this function is kind of the inverse. It will get the file, it's given the file path to your QR code, and it makes sure that that file path is valid. Then it will use the CV2 library to read that image in, and it will use the QR code detector to translate that QR code into its data again. and then it will parse that data out, return it, make sure it's all good. Does this code make sense? Pretty straightforward. So we are going to test the QR codes module that we have written here. Because big problem right now is you can write the code, but it is as of yet untested, and that means it's dangerous. What if we screwed something up? What if it'll allow people other than me to use my account to get on the metro? Ouch, that could be painful. So how do we go about testing this? Well, we could actually start by testing it manually. You can do this from the Python interpreter. Python interpreter is wonderful for this kind of manual exploration. And I believe all automated tests originally start with manual attempts to exercise their behavior. And so if I open up, I just type Python at the command line, boom, I'm in my triple arrow interpreter. We're going to import that module, QR codes. Then we're going to set up some test data. I need a commuter ID, which is just some random GUID. I need a security token, which let's just say it's like some 40-character long alphanumeric. And then I also need a file path that I want to save and retrieve my file from. And we can call it, local payment code.png. Then what I can do is I can directly from the interpreter call my function generating the payment code, put in my test data. And okay, so that, as we know, is going to store, or it's going to generate that QR code in that file. And then after that file is created, I can read it back and I can check to see if the data is right. So once I do this, bam, it's going to give me the data that was translated from my QR code, and I can verify with my eyeballs. Do they match? Do they match? Yeah, woo! Test passed, yay! We verified it. Awesome, cool. Now, this is great for a one-off check, but this test is slow, right? Because I have to manually type everything in. Maybe I'm smart and I copy paste, but ultimately, rerunning this test would be way, way too slow. And so what we ought to do is we ought to script this test case. So we're going from now manual testing to automated testing. And here with my lovely escaladral diagram, the beauty of a scripted test is that you can run it again and again and again and again and again, right? You don't have to manually poke and prod these things. You can just have it go for you. That is the beauty of automation. So let's do that. Thankfully, it's not too hard. We've already written out our steps in the interpreter. All we need to do is just kind of copy paste those into a new Python module. That can be the starting point of our test script. And so this code in our test script, let's call it test_QRcodes.py. This looks a lot like what we shoved into the interpreter, doesn't it? It's pretty much the same. The only thing I did to jazz it up is I added some comments for guidance. I added some given, when, then steps. Whenever I write a test case, I like to follow the arrange, act, assert pattern. Has anybody heard of this pattern? Yes, yes. Awesome. So what arrange, act, assert is a way to set up your functional test cases such that they focus on behaviors individually and independently, that there would be one behavior per test. You arrange, you set up your test. That would be what's going on here with the test data, the commuter ID, the security code, and the file path. You act upon the behavior, and that would be calling those two QR code methods. And then you assert that some expected outcome has happened. And so that's right now kind of what we're seeing in the final print statement to show what that QR code data is. I also like to, when I follow arrange, act, assert, I like to write out my steps in plain language using given, when, then formats. Given, when, then, if you've seen that before, that's what we call the gherkin format. Anybody who's done the BDD thing? If you haven't, no worries. But what I like to do is I like to separate my test case from my test code in that sense, because there's a difference between writing a whole bunch of scripts and also thinking about what the behavior should be. Hence, we have this here in our test script. And so if we run this, again, we can now, instead of running just raw terminal, we run our script, we can see, hey, it runs the thing and it prints it out. Very good. And so as we recall, this data looks like the ones we got before. Cool. Are we good? No, this actually sucks. Because the test result is unclear. If I look at this, how do I know this is right or wrong? I still would have to do the mental taxation of like, oh, let me go back in my test data and like look at these horribly long strings and eyeball and hope I don't get it wrong. It's kind of like that whole regex or noise challenge from yesterday. So yes, this result is unclear. Automated tests are meant to help us. They're meant to bring clarity. They're meant to yield helpful information so that we have to work less. So let's fix that. Ultimately, when we have a functional test case, we want to run this test and get some sort of binary output that is pass or fail. We can hard code those assertions in there. Did it work or not? I don't know. You tell me, Mr. Automated Test. That's what we're looking to do here. It shouldn't just print out something to the screen. It should make an assertion. And it should be clear. And it should be binary and discrete. So here's how we could add an assertion to our test case. For brevity, I've removed the comments from the previous slide, but in a real code, I would still keep it there. And so the lines are pretty much the same. We had that upper paragraph that sets up our test cases, that's the arrange. We still have the calling of the method or the functions, that's the act. And I still even included the print statement for now, that doesn't hurt. But then what we do in this red box is we are then concatenating what the expected result is going to be. Right? We have the actual results of the data, now we have an expected result. I'm printing out what that expected result should be, and then I'm performing a condition. If the actual result equals the expected result, I'm going to print pass or fail, right? Pass, yes it is, and if it's not, fail, no it's not. So if we rerun our script now, bam, not only do we see the data that is yielded, which is very helpful for troubleshooting and all, but we can see a very clear test result. Ah, this was good. I don't have to like eyeball it and try to figure out if it was the same or not. The computer did the work for me. Yay, much better, right? Yeah, this is better, we're getting there. Well, we've only done the happy path of the testing so far, right? And it's a good test, okay, we wanna make sure we have that, but we ultimately need other tests as well. And talking with Josh the other day, he made a really good comment. He said something like, the surface area of negative testing is infinite. I'm like, yeah, that's true. So we could add a lot more tests for these very simple functions. So let's go ahead and add one. Same kind of format. Let's make another file, I don't know, test non-existent path.py or something. And we're gonna set up the Python script, plain and simple like we had before. But this time, the test case data is a file path that does not exist. And so what we do is we try to scan the payment code using that file path. And what we expect to happen is pardon me, is that if we put in an invalid path, that it should raise a value error, right? Because that would show, we gave it a bad value. And so in that case, if it raises a value error, we'll mark it was raised. And in the other cases, like if in the try block, if it didn't raise an exception, nothing was raised. Or if it raised another type of exception, it didn't raise a value error. So we'll raise false. And at the end, again, we make our assertion. If we raise the value error, we pass. Otherwise, we failed and something went wrong. So we wrote this test, yay, and we could run it the same way. Wonderful, skippity-doo-dah. But what if we have to write a third test? What if I need 100 tests? It's very common, even in moderately sized projects, for the number of the test cases you have, whatever level, unit integration end-to-end, to stretch into the hundreds, if not thousands. Am I right? Yeah, oh my gosh. Yes. So we need a better way to manage all of these tests together. And so we think about this like, okay, I shouldn't have to like go and manually trigger every single individual test case script. That's not scalable. Instead of treating these test cases as individual scripts, maybe we need to treat each test case as an object. And I use the word object very loosely here. But if we treat them as an object, then I can create something of a test runner and line them up and run them all at once. Kind of like those dominoes I mentioned before. So let's see what that looks like. Conceptually, it looks kind of like this. When I have a test suite, ultimately I want to start my test suite and run test case 1, test case 2, test case 3, all the way until the very last test case. And then at the end, I want to print out all of the results of the entire suite together. This is the basis of a test runner. So it doesn't take too much to convert our scripts from what we had before. let's just be very basic. We can take the script and ultimately make all that code that was kind of main-esque and turn it just into a class. And so here I have, what's it called? Test QR code generation. And inside the body of the test is now inside a method called run. And for the other one, I have test QR code scan path where I did the same kind of pattern. Plain old Python objects for now. Duck typing means that we can run the run method on each one of them. It all magically works. Yay. Cool. So now that I've turned those into test classes, I also need a test runner class. So here on the left, I have a basic class called test runner. When I initialize the test runner, it's initialized to a list of tests that is empty. I can add tests to my test runner, and that's with the self-test append. I could be more clever and do other things here, but it's good. Remember, there's small peanuts here. And then I have a run method for my runner. And in my run method, what it does is it iterates over the list of tests and runs each one. Simple, right? And so then when it comes time to run my suite, I also need a little bit more code. I import all the things. I import the test runner object or the class. I import the different test cases, and I can set up my runner like this. Create the test runner object, add the different test cases I'm instantiating, and then run them all at once. Make sense? Pretty straightforward, right? Yeah. And so the output now is going to look like this. Instead of running each and individual script, I'm going to run the run all tests py script that will call the runner that calls the tests. And essentially, I'm going to get the same output as I did before. It's just now I can do it all in one run. Sweet. My domino runner is great. Cool. Anyone see a problem here? Yeah, what's the problem? Too noisy. Well, there's a lot of problems. That's probably a broad question. I should not have. It's okay. I'm slow. Forgive me today. One problem with this, though, is if you line up all of your tests, one after the other, if one of the tests explodes with an unexpected error, what's going to happen? The whole suite's over, right? Kaboom! That's not good. These tests are not treated independently, when in fact they should be. Because here's what's going to happen. Let's say on test case 2, there's an abortive failure. If that happens, it interrupts the entire process. And so there's a failure, it escapes, the test is over, kaboom, and you essentially have a test gap for the remaining tests that are effectively skipped, right? And this is a problem. We don't want that. We want to be able to run as much as we can safely at one time and get the results of everything. What we really want is a runner like this, where anytime there is an interruptive failure, there is recovery. And the recovery mechanism is not to be handled at the level of the test case, but rather at the test runner. Why? Because the framework should work for you, not the other way around. The framework should handle the common concerns across all test cases, letting you focus on the business logic of what you need to cover in the behaviors of your tests. And so if we have this kind of recovery mechanism in the framework, then it can log the failure and keep moving on to the next tests without interruption. So let us make our test runners safer. And it's actually not too hard to do. So in the run method, inside that for loop we have, all we got to do is wrap our run method in a try except block. And so anytime there's any kind of exception that happens, we can just print, oh, this test failed, and here's the reason for the exception. And so then what will happen is anytime we have a test that fails, like up here on the right, whether that's a soft failure or a hard failure, whatever kind of failure you have, it will be handled safely, and the rest of the test will still run. Still, though, there's information lacking here. In the report output we saw, we just kind of see this list of pass and fail and pass and fail. That's okay if we've got a handful of tests. But as we said before, our test suites can stretch to hundreds to thousands to even larger quantities of tests. And there's no way that a human is going to read through every little line to find a failure. What we really want is better test reporting. And specifically, we want our test framework to tally up the results. So we know, hey, here's the percentage of passing tests. And then we would also like for our framework to drill in and say, here were the particular failures. If you have a test case passes, it's good to know that, great, but you don't need a whole lot of information. If you have a failing test case, that's what you want to be noisy. So what we want, again, with our beautiful Excalibur diagram is something that looks a little more like this, where after we're running our test cases 1 through n, the output is not just puke on a screen, it's actually a more detailed test report to tell me exactly everything that happened. So we need to change how our tests are written a little bit. And so in our test case object, not only should we have a run method, but we also need to somehow give it a name, right? Because if we name behaviors, then we know exactly what they're doing. And so here, what I've done is I've created an init method in my Python object class thingy-dingy, and I've given it a human name, human readable name, generated a QR code for a commuter. And then also at the bottom, I have decided to use an assertion, an actual real assertion, not just a print statement. Python assert is in the language. You can use it for anything. It is ideal for test cases. And so I'm going to use the assert statement for comparing my expected to my actual data. And what will happen with this assert statement is, if it passes, we're clear. If it fails, kaboom, assert error goes up. And that will get handled by our framework and be logged as a failure. Because we just did that safety thing, didn't we? All right. So then on the reporter itself, we need to add some more richness to what is reported. And so here now, we still have the, that for loop that runs all the tests. But we now also have to have data tracking which tests are passing and which are failing. So that's those lists at the top. We've also added a few more print statements here, which is fine. And then at the end of looping through all the tests, we have a final summary report as well. And for simplicity, we're just going to put this out on the console. And so it gives a nice little test banner. And then for all the tests that we're passing, it prints them out. All the ones that were failing, prints them out. And then it tallies up at the very end, what was the length of the lists of each passing and failing, so I can say exactly how many were in each category. And I didn't put it here, but I could have also done like a division and put a little percentage as well. That's also kind of cute. So now when I run these tests, now we're looking pretty sharp, right? I'm running my main runner script. It shows me when I'm starting each of the test cases. And that's just there for like trace so you can see as it's going along. And then finally at the end, you get a much better summation and tally of what your tests actually did. And so here in our micro project with 2 tests, in this case, they both passed. Yay. Isn't this nice? Isn't this wonderful? Are we there yet? Have we built a test framework? Well, technically we have built a test framework. Would you use this in production? And when production, I mean to say continuous integration is the production environment for test automation. Oh, that changes our view on testing, doesn't it? But is this production ready as a framework? No. There is more that we ought to do to make this kind of test framework production ready. More than I can show in this half-an-hour talk. I could write a book about this. In fact, I'm trying. Sorry, Manning. But there are many more features. Wow. There are many more features that we ought to add to a test framework for it to really serve our needs. We didn't even get into writing setup and cleanup routines. Can you imagine the Excalibur diagram I'd have to write for that one? Right? Oh man, right? What about parameterizing test inputs if you want to run the same procedure for multiple different input combos? What about filtering your tests by name or path? So instead of running your whole suite every time, you can pinpoint and target. What about discovering available tests to say what is in my projects? What about generating richer reports? Where instead of just puking it out on a console, what if you want these beautiful web dashboard pages, or if you need to scuttle it off with an API to something else? And the list goes on and on and on. And so at this point, I say, hey, let's stop for a moment. This is becoming too much. We are spending so much work on this fledgling framework already, and it is still so limited. We shouldn't be in the business of writing our own test framework, should we? No. So in going through this today, I hope that you have learned, the intricacies of what it means to build a test framework, that there's a deeper understanding of the principles of good testing and automation here. But I hope you also learn that you should not just make your own test framework on your own, right? There's no reason in 2025 for you to do this yourself. Just use an existing test framework. There are awesome options out there, namely PyTest. How many people have used PyTest? PyTest is is awesome, isn't it? I love PyTest. I dance in and out of different languages and stacks. I've used many, many different test frameworks, good and bad. And my honest opinion is PyTest is the best. It really is. Of all the test frameworks I've used, I think PyTest is the most excellent. And so for us here as Pythonistas, we recognizing that we will never reach feature parity with something as mature and awesome as PyTest. Why don't we just use PyTest? Right? Simple. Bam. And so here's what our test case would look like written in PyTest. I know the code might be a little bit small, but with PyTest we can use fixtures to handle setup and cleanup. In fact, there's a little bit of extra setup and cleanup in that file path fixture, where not only does it give you the path, it does some file system checking, and at the end of the test, it'll automatically delete that file that was generated for test data. And then our test case function itself is very, very concise. So, yes. So one final thought I want to leave you all with. When we think of the great disciplines within software, we often think of things like web development, distributed systems, backend, compiler theory, networking, all these kinds of things that we probably learned in school. Databases is another good one. But I want to assert that software testing is also one of the great disciplines. Yes. It is often overlooked. It is often dismissed, but it is one of the greats. There is complexity, there is richness, and there is beauty. And believe me, there are career-long opportunities in it. So rather than be so bold as to think you can make your own test framework and do it all yourself, I would humbly submit to you, why not instead stand on the shoulders of giants? Build upon what is already there. Because it's not impossible to do testing. Even though it is challenging, it can also be rewarding. Team up and use the things that are already there. So the final version of this talk is do not build a test framework from scratch. Yes. Thank you very much. My name is Pandy Knight, Automation Panda.